1. Every pool owner knows the pH correction drill. Test the water. pH is too high? Add pH down. Test again the next morning. pH has climbed back up. Add pH down again. Test Thursday. Still climbing. Add more test Saturday. Back above 7.8. Repeat. The correction works temporarily and then stops working, and you are standing at the edge of the pool with a test strip reading the same number it was reading before you added the last bottle, wondering why a chemistry problem that should have a straightforward fix keeps refusing to stay fixed. The answer is not a better product. 1. The answer is not a larger dose. The answer is that pH correction without the underlying fix is the same as bailing water out of a boat with a hole in it. You can bail faster. You can use a bigger bucket. The boat keeps sinking because the hole is still there. The pool store sells you a bigger bucket every visit and never mentions the hole. The hole in pool pH management is total alkalinity, and until it is fixed correctly in the right range, no pH correction you make will hold for more than a day or two before the same forces that moved pH in the first place move it back again. 1. Fix the hole, and pH corrections made in 10 minutes stay fixed for weeks. Do not fix the hole, and pH corrections made for an entire summer fix nothing permanently. 90% of pool owners who fight pH problems all summer are fighting pH while the real problem runs uncorrected underneath it. 1. By the end of this video, you will understand exactly what the hole is, why it keeps pH unstable regardless of how many corrections you make, the 10-minute method that fixes it permanently using a 1 grocery store product, and the complete system that means you make 1 pH correction this season instead of 1 every 3 days. Walk into the pool store with a pH problem, and the conversation ends in one place. A bottle of pH up or pH down depending on which direction your pH is drifting. The product corrects the number you leave satisfied. 3 days later, the number has drifted back, and you are in the same conversation with the same counterperson buying the same product. The pool store is not selling you a solution to your pH problem, it is selling you a temporary correction that generates repeat purchases because the actual cause of your pH problem is never addressed. And the actual cause, the one that is never mentioned, is total alkalinity. Total alkalinity is not just another number on the test panel. It is the chemical mechanism that determines whether pH can stay where you put it, or whether it will drift the moment any force acts on the water. And in a residential pool in summer, forces act on the water constantly. Aeration from jets, splashing, and waterfalls drives carbon dioxide out of the water and pushes pH up. Swimmer load introduces carbon dioxide from exhalation and pushes pH up further. Liquid chlorine additions nudge pH upward. Trichlor tablets push pH downward over time. Rain pushes pH down. Each of these forces is acting on your pool water all day, every day through the swimming season. In a pool with total alkalinity between 80 and 120 parts per million, these forces hit the alkalinity buffer, and the buffer absorbs them. pH barely moves, corrections made stay made for days or weeks because nothing is powerful enough to overcome the buffer. In a pool with total alkalinity below 60 parts per million, these same forces move pH freely and rapidly. 1A pH correction made at 8 in the morning can be undone by noon just from the aeration produced by a running waterfall and normal swimmer activity. This is why pH corrections do not hold, not because the product is wrong, not because the dose is insufficient, because the buffer that should be holding pH in place is inadequate, and every force acting on the water overwrites the correction within hours. You are correcting the symptom. Total alkalinity is the cause. Fix the cause and the symptom stops recurring. Total alkalinity is a measurement of the concentration of bicarbonate, carbonate, and hydroxide ions dissolved in pool water. These ions function as a chemical buffer, meaning they resist changes to pH by chemically neutralizing the acids and bases that would otherwise shift pH freely. Higher alkalinity within the correct range means more buffering capacity. More buffering capacity means more resistance to pH change. More resistance to pH change means corrections hold longer and the daily chemistry maintenance requires fewer interventions. The reason the pool store does not make alkalinity the first conversation when you bring in a pH problem is the same reason the pool store does not make any root cause the first conversation. Root causes, once addressed, eliminate recurring purchases. A pool owner who understands that low alkalinity is causing their pH instability goes to the grocery store, buys baking soda, raises alkalinity to the correct range, and stops buying pH correction product every week. That owner's product purchases drop significantly. The pool store has no financial incentive to make that conversation happen. The product the pool store sells for alkalinity correction is called Alkalinity Up or Total Alkalinity Increaser. The active ingredient on the back of every version of this product is sodium bicarbonate, baking soda. The same compound in the orange box in the baking aisle of every grocery store in the country. The pool store sells it for $15 to $20 for 4 pounds. The grocery store sells it for $1 a pound. The pool store version costs 4 to 5 times more per pound for the identical compound. Raising alkalinity to the correct range using grocery store baking soda costs $3 to $8 for most residential pools. The pool store version of the same correction costs $15 to $30. And unlike pH correction product, which generates repeat purchases every week, the alkalinity correction done correctly lasts for weeks before it needs attention again. It is the cheapest, most durable fix in pool chemistry. It is the last thing the pool store wants to be the first recommendation. This section is the practical core. Every step matters. The sequence matters. 1. The one step most owners skip is the step that determines whether this fix lasts 10 days or 10 minutes. Do not skip it. Step 1. Test total alkalinity accurately. Not with a test strip, with a drop test kit. Test strips give directional alkalinity readings that are adequate for confirming a ballpark range but not accurate enough to dose a correction correctly. The difference between an alkalinity reading of 60 and 80 on a test strip could be the difference between adding too much baking soda and overshooting into the range where pH becomes difficult to adjust. 1A drop test kit costs $15 to $30 and gives you the accuracy needed to calculate the correct dose. Write the number down. Your target is 80 to 120 parts per million. For the maximum pH buffering benefit, aim for the upper end of that range, 100 to 110 parts per million. A pool sitting at 110 alkalinity resists pH swings more effectively than one sitting at 85 because there is more buffer capacity available to absorb the forces acting on the water. Step 2. Calculate your dose. For a 10,000-gallon pool, 1.5 pounds of baking soda raises total alkalinity by approximately 10 parts per million. 1. If your pool is 10,000 gallons and your alkalinity tests at 60 parts per million and your target is 100, you need to raise alkalinity by 40 parts per million. That requires approximately 6 pounds of baking soda. If your pool is 15,000 gallons, multiply by 1.5. If it is 20,000 gallons, multiply by 2. The math is linear and straightforward. Do not add the full dose at once. Add it in 2 stages separated by a 2 to 4 hour retest. Add half your calculated dose, run the pump for 2 hours retest. Then add the remainder if needed. Alkalinity is easier to raise than to lower. One overshooting above 120 creates a different problem where pH becomes resistant to correction in either direction. 2-stage addition prevents overshoot. Step 3. Add the baking soda correctly. Pump running. Broadcast it across the surface of the pool as you walk the perimeter rather than dumping it in one location. It dissolves within a couple of hours of normal pump operation. Do not add it directly in front of a return jet because the concentrated undissolved compound can briefly affect local pH in a way that looks alarming on a spot test. 1. Broadcast evenly and let circulation do the mixing. Step 4. Wait 4 hours before testing pH. This is the step most owners skip and the one that makes this fix fail. Alkalinity corrections take time to fully stabilize in the water. Testing pH 1 hour after adding baking soda gives you a reading that does not reflect the stabilized chemistry. Wait the full 4 hours, then test pH. With alkalinity now in the correct range, assess whether pH needs adjustment and make any needed correction knowing that the buffer is now in place to hold it. Step 5. Correct pH if needed after the alkalinity is stable. pH too high, above 7.6. Add muriatic acid from the hardware store, diluted in a bucket of pool water, poured slowly at the deep end with the pump running. pH too low, below 7.4. Add borax from the laundry aisle. Make the correction now with the buffer in place, and watch what happens over the next 48 hours. pH that was drifting back within hours before the alkalinity fix now holds for days. Sometimes for a week or more without any additional correction needed. That is the 10-minute fix. 1. Test, calculate, add baking soda in 2 stages, wait, correct pH. The actual hands-on time is under 10 minutes. The waiting periods between stages are not work. They are chemistry happening while you do something else. Baking soda raises alkalinity and creates a bicarbonate buffer that resists pH change. Borax, added separately to establish a borate system, creates a second buffer layer that works alongside the alkalinity buffer to provide even stronger pH stability through the specific forces that residential pool water faces in summer. 1. The borate system works differently from the alkalinity buffer, where alkalinity buffers against both acidic and basic inputs broadly. The borate buffer specifically resists the upward pH push produced by aeration, the single most consistent force pushing pH higher in a residential pool all day in summer. Jets, waterfalls, splashing, cannonballs, and the simple act of people moving through water all drive carbon dioxide out of the water and push pH up. The borate buffer absorbs these aeration-driven pH pushes and holds pH in range through the afternoon when aeration is at its peak. 1A pool with alkalinity at 100 parts per million and borates established at 30 to 50 parts per million has 2 independent buffering systems working simultaneously. The alkalinity buffer handles broad pH resistance. The borate buffer specifically handles the aeration-driven upward pH push that is responsible for most of the pH drift residential pool owners fight on hot, active summer afternoons. Together, they create a pH stability that most pool owners have never experienced because most pool owners have never had both systems running at the same time. 1. To establish the borate system alongside the alkalinity fix. Add borax from the laundry aisle after the alkalinity correction is complete and stable. 20 pounds for a 10,000-gallon pool raises borates from 0 to approximately 50 parts per million. Add with the pump running, broadcast across the surface, then correct pH afterward with muriatic acid since borax raises pH by approximately 0.5 units. Retest the following morning once the system has stabilized. 1. With both alkalinity and borates in range. The pH drift that previously required correction every 2 to 3 days requires correction once a week or less. If you want every dose, every correction calculation, and the complete grocery store substitution guide in one place, I put it all together in a 39-page guide called the Pool Carder Playbook, from green to crystal clear. Normally $67, right now just $29.99. It covers the full grocery store method with exact doses, the SLAM process for green pools, a printable weekly routine, and the 5 numbers that run your entire pool all season. 1. I went from spending $600 a season to under $150, and my water has never looked better. The link is below this video. 7-day refund guarantee, instant PDF download. Let's finish the system. Pool owners fight pH in 2 directions. High pH is far more common than low pH in residential pools, particularly in summer, and understanding why helps explain why the borate plus alkalinity system targets the upward drift specifically. pH rises in pool water through 4 primary mechanisms. Aeration is the most constant and most powerful. Any process that agitates the water surface and drives carbon dioxide out of solution raises pH. Jets, waterfalls, fountains, splashing swimmers, wave action, and even wind across the pool surface all aerate the water and drive pH upward. A pool with an active waterfall feature running all day is fighting a constant upward pH push that a pool without aeration features faces in a milder form. The borate buffer specifically addresses this mechanism. Swimmer load is the second mechanism. 1. Carbon dioxide from swimmer exhalation dissolves in the water and converts to carbonic acid, which sounds like it should lower pH. But the net effect of heavy swimmer load, including body heat, sweat, and the physical disturbance swimmers create in the water, is typically a mild upward pH push in most residential pools. A pool that handles 10 swimmers on a Saturday afternoon will often test slightly higher pH on Sunday morning than it did Friday evening. Liquid chlorine additions are the third mechanism. 1. Sodium hypochlorite, whether added as pool store liquid chlorine or grocery store bleach, has a high pH in concentrated form. Added to pool water, it raises pH slightly with each addition. In a pool where daily bleach additions are the primary chlorine source, pH tends to drift upward slowly over the course of a week. The alkalinity and borate buffers absorb most of this drift, which is why well-buffered pools require less frequent pH correction even when using liquid chlorine as the primary sanitizer. Calcium hypochlorite shock is the fourth mechanism. 1 cal hypo has a high pH, and a single shock dose can raise pool pH noticeably, particularly in smaller pools. Testing pH the morning after a shock treatment and making a minor correction with muriatic acid is standard practice in the system. This video covers. Understanding these 4 mechanisms explains why pH almost always goes up in summer rather than down, why the borate buffer targeting aeration-driven pH rise is specifically valuable, and why muriatic acid from the hardware store is used far more often than pH-up products in a properly maintained residential pool. 1. The water is being pushed up constantly. The system holds it in range. And the rare occasion when pH drops is handled with a small borax addition rather than a specialty product from the pool store. Once at the start of the season, establish alkalinity at 100 to 110 parts per million with baking soda. Establish borates at 30 to 50 parts per million with borax. Correct pH to 7.4 to 7.6 after both are established. These 2 buffer systems are the foundation of the permanent pH fix. Everything else in the system runs on top of them. Every morning in July, 2 minutes. Test pH with a test strip. 1 pH above 7.6. Note a muriatic acid correction for dusk. pH below 7.4. Note a borax addition for dusk. With both buffer systems in place, most mornings in a typical residential pool will show pH within range and require no correction at all. The occasional correction when it is needed is small and takes 2 minutes at dusk. Every week, 15 minutes, run the full panel including total alkalinity. Alkalinity drifting below 90, add baking soda to bring it back to 100 to 110. 1. This happens less frequently than most pool owners expect because the borate system reduces the alkalinity fluctuation that aeration produces. A pool with borates established loses alkalinity more slowly than an unbuffered pool because one of the primary alkalinity depleting mechanisms, the constant aeration correction cycle, is significantly dampened. When alkalinity does need correction, the addition is small, 2 to 3 pounds of baking soda rather than the 6-pound initial correction. Add with the pump running, wait 4 hours, retest, confirm. Done. 1. What the weekly panel almost never shows in a pool with this system running correctly is a dramatic pH problem requiring a large correction. Because large pH problems develop from uncorrected drift. Uncorrected drift happens when either the buffer systems are inadequate or the daily check is not happening, with both buffers in place and the daily 2-minute check catching any drift before it becomes significant. The weekly panel confirms that the system is working correctly and makes minor adjustments rather than major corrections. 1. Run this math once, and the decision to fix alkalinity permanently rather than correct pH repeatedly becomes financially obvious. pH down product from the pool store, $15 to $22 per bottle. Purchased twice a month through a 5-month summer season by an owner with persistent high pH, $150 to $220 per season. This owner's pH problem never gets permanently fixed because low alkalinity is the cause and pH down does not address alkalinity. The same purchase recurs every season, every year, for the life of the pool. 1 baking soda from the grocery store for the alkalinity fix, $6 to $9 for the initial correction. Borax from the laundry aisle for the borate system, $8 to $10. Muriatic acid from the hardware store for occasional pH corrections, $10 for a gallon that lasts most of a season. Total first season cost for the permanent fix, $24 to $29. Same pool, same pH problem. One approach costs $150 to $220 per season indefinitely. The other costs $24 to $29 the first season and $10 to $15 per season thereafter for muriatic acid top-ups. 1. The permanent fix pays for itself in the first month and saves $120 to $200 every season after that, for the life of the pool. The pool store is selling you the recurring version of this problem because the recurring version generates recurring revenue. The permanent version, a $1 per pound grocery store product and a $10 hardware store acid, generates one purchase and then almost nothing after that. From the pool store's perspective, the permanent fix is the worst possible outcome. From yours, it is the obvious one. Look at every pH correction you have ever made in your pool and find the common thread. The correction worked. The correction did not hold. The correction was repeated. That pattern is not a product failure. It is a system failure. The product corrected the symptom correctly. The system that should prevent the symptom from recurring was not in place, so the symptom recurred. The alkalinity and borate system is not a pH correction. It is the removal of the conditions that make pH instability possible. 1A pool, with alkalinity at 100 to 110 parts per million and borates at 30 to 50 parts per million, is a pool where the chemical environment resists the forces that push pH out of range. When pH does drift, it drifts slowly and in small increments rather than rapidly and in large swings. A small drift caught in the morning 2-minute check becomes a small correction at dusk. A small correction at dusk becomes a pH reading back in range by morning. That cycle, small drift, small correction, back in range, is what pool pH management looks like when the system is running correctly. It is a 20-second daily observation and a 2-minute dusk addition on the days when a correction is needed. The rest of the time, the buffer systems are doing the work while you do something else. The owner, who has been buying pH down twice a month for 3 summers, has been paying $150 to $220 a season to manage a problem that $30 in grocery store and hardware store products would have removed permanently. The 10-minute fix is not a life hack or a clever workaround. It is the correct solution to the actual problem that the pool store was never going to point you toward. 1. If this is the summer, you fix the hole instead of bailing the boat, drop it in the comments. How long have you been fighting pH, and what has it cost you across the seasons? Help the next owner skip the recurring correction cycle before it costs them another summer. Every video on this channel works the same way. Real numbers, no sponsors, no pool store upsell. If that is useful to you, subscribe. This channel reads the water, not the marketing.